Today we are going to see both methods, block diagram reduction as well as signal flow graph method. Both methods we'll see another two sums on this method. Given that the block diagram is given, we have to find the C of S upon R of S by using block diagram reduction method. In this, the first step is we have to find the innermost part of the loop. This is the innermost part. This can be easily converted. This can be easily converted to G4. This part is equal to negative feedback. That's why this is equal to G4 upon 1 plus G4H2 by using 7th rule. By using 7th rule, we can write like this. This also can be written. No need to write separate two summing blocks. This also can be. But summing block will be there because of this path. Because of this path, summing block will be there. But this feedback path can be removed by using 7th rule. This is equal to G1 upon 1 plus G1H1. These two are in parallel. These two are in parallel. That's why this can be written as G3 plus G2. Now, the block diagram can be reduced to G5, G4 among 1 plus G4H2. These two are parallel blocks. That's why G3 plus G2. And this is feedback. That's why we can write G1 among 1 plus G1H1. In the examination, you have to separate these two summing blocks in one step. Then you have to find the transfer function for these two loops. And then you have to add. The third step, you have to add these two. But here in one step, I did all the three things together. But in the examination, to give more steps, I do not know about the examiner. If I am going to be the examiner, no problem. So do more number of steps. You have to separate this summing block into two summing blocks. One, this forward path, another one for feedback. Like that, you have to separate this into two summing blocks. So now we can multiply all these together. This is equal to G5, G4, G3 plus G2 multiplied by G1 among 1 plus G4H2 multiplied by 1 plus G1H1. This is one step. Again, you have to draw like this. G1, G2 plus G3, G4, G5 upon 1 plus G4H2, 1 plus G1H1. Now we have to apply 7th rule. RC. If you apply 7th rule, what you will get? C of S upon R of S equal to G1, G2 plus G3 multiplied by G4, G5 upon 1 plus G4H2 multiplied by 1 plus G1 H1. This is in the numerator. Forward path upon 1 plus G1, G2 plus G3, G4, G5 upon 1 plus G4 H2 multiplied by 1 plus G1 H1. If you take LCM, you will get G1, G2 plus G3, G4, G5 upon 1 plus 1 plus G1 H1 plus G4 H2 plus G1 G4 H1 H2. I expanded this part. Upon, if you take LCM of this, what you will get? 1 plus G1 H1 plus G4 H2 plus G1 G4 H1 H2. This is instead of 1, because I am taking LCM, whole divided by plus this part we have to write. Numerator part we have to write. So G1 plus G2 plus G3, G4, G5 whole divided by 1 plus G1 H1 plus G4 H2 plus G1 G4 H1 H2. These two are getting cancelled. Therefore, the transfer function is C of S upon R of S equal to G1, G2 plus G3, G4, G5 upon 1 plus G1 H1, G4 H2, G1 G4 G1 G4 H1 H2 plus G1 G2 G4 G5 G4 G5 plus G1 G3 G1 G3 G4 G5. If we expand this also, you will get the numerator G1 G2 plus G1 G3 G1 G2 G4 G5 plus G1 G3 G4 G5, the numerator. Instead of this, in the numerator you can write G1 G2 G4 G5 plus G1 G4 G5 G3. The numerator. Instead of that, you can write this. So we got this. Why I expanded all this? Because if you use signal flow graph, you will get like this. To verify, it will be convenient. Otherwise, you can stop without simplifying, without expanding. So in the signal flow graph, we have to draw signal flow graph. We have to find the signal flow graph. This is source node. R is the source node 1. This is second node. This is third node, fourth node, fifth node, sixth node, seventh node, and the eighth node is the sink node. Eighth node is the sink node. Now we have to draw the signal flow graph. How many nodes? 8 nodes are required. G3, G2, G1, 1. This is also 1. This is 5, 4, 6, 7, 8. 7 to 5. One path is there, feedback path, H1 minus H1 because negative feedback. 4 to 3. That is also minus H2. 7 to 2. One more feedback. 7 to 2. That is minus 1. That's all. This is the given signal flow graph representation of given block diagram. Now we have to find the transfer function. What is the formula? Mason's gain formula. T of S equal to 1 upon delta sigma Pk delta K. Here also only 2 forward paths are there. Only 2 forward paths. One is 1, 2, 3, 4, G3, 5, 6, 8. Another forward path is 1, 2, 3, 4, G2, 5, 6, 8. Therefore, P1 equal to G5, G4, G3, G1. Another forward path, P2 is the circular path. We have to go through this path instead of this path. So P2 equal to G5, G4, G2, G1. Only 2 forward paths. Then we have to find the delta. To find delta, we need the loops. L1. The first loop is this. Minus G4, H2. Another loop, L2 equal to. This is not loop. This is not loop. Because the direction is not in favor of travel. But this is loop. 5, 6, 7, 5 is loop. That is minus G1, H1. Another loop. One more loop. 2, 3, 4, 5, 6, 7, 2. That is one more loop. L3 equal to minus G5, G4, G3, G1. That's all. L4 equal to another path we can find 2, 3, 4, G2, 5, 6, 7. That is another path. Therefore, that also can be written minus G5, G4, G3, G2, G1. That's all. G5, G4, G2, G1. Any other loops? Individual loops? No other loops. No other individual loops. This is not the loop. Between 4 and 5 is not the loop because the direction is not in favor to travel. But 2 non-touching loops are there. 2 non-touching loops are there. 3, 4, 5, 6 are 2 non-touching loops. 3, 4 and 5, 6 are 2 non-touching loops. That is G4, H2 is what? G4, H2 is L1. L1. G1, H1 is L2. G1, L2 is a non-touching loops. 2 non-touching loops. L1, L2. What is the gain? Plus G1, G4, H1, H2. That's all. No three non-touching loops. Definitely no, because two non-touching loops only there. How three? That's all. So we can find the delta. What is delta 1? Delta 1 is delta of part of graph which is not touching the forward path, first forward path. What is first forward path? G4, G5, G4, G3, G1. That is the first forward path. The part of graph which is not touching the forward path is only one node, that is 7. 7 is not touching the forward path. Suppose in the 7 you have a loop like this, that is called self loop. I didn't mention yesterday. That is called self loop. I am having a loop like this whose gain is G6, let us assume. Then that is equal, that will come in part of delta 1. But no such loops are there. But only one node is there. 7 is not touching the forward path. That's all. There is no loop. Therefore, delta 1 equal to 1. That's all. What is delta 2? Delta 2 is the another forward path. G5, G4, G2, G1. That is delta, forward path 2, P2. Forward path 2 is G5, G4, G2, G1. Part of graph which is not touching the second forward path is again 7 only. But 7 doesn't have any loop. 7 doesn't have any loop. The loop should not touch the forward path. But here 7 has one loop. 7 has one loop. That is G1, H1 is there. But it is touching the forward path. A part of graph which is not touching the forward path we need. But only one node is not touching. There is no loops which is not touching the forward path. Therefore, delta 2 also equal to 1. Delta 2 also equal to 1. Therefore, the transfer function is C of S upon R of S equal to P1 plus P1 delta 1. Formula is what? P1 delta 1 plus P2 delta 2 among delta. That's all. What is P1? P1 is G1, G3, G4, G5 multiplied by delta 1, that is 1, plus G1, G2, G4, G3, G4 multiplied by 1. P1 plus P1 delta 1 plus P2 delta 2 upon delta. Delta equal to what? Delta equal to 1 minus L1 plus L2 plus L3 plus L4 plus L1 L. That's all. Plus L1 L. This is delta. What is the formula for delta? 1 minus sum of gain products of individual loops plus sum of gain products of two non-touching loops. Only one, two non-touching loop, L1, L2. Therefore, delta equal to 1 minus, what is L1? L1 is minus G4 H2. L2 is minus G1 H1 minus G5 G4 G3 G1 minus G5 G4 G2 G1 plus L1 L2 is what? G1 G4 H1 H2. That's all. Only thing is you have to bring that minus sign inside. If you bring that minus sign inside, what you will get? Everything becomes plus. That's all. If we check with that block diagram reduction method, G1, G4, H1, H2, that is there. G1, G4, H1, H2 is there. G5, G4, G2, G1, that is also there. G5, G4, G3, G1, that is also there. G1, H1, that is also there. G4, H2, that is also there. 1, that is also there. Numerator, G1, G3, G4, G5 is there. G1, G2, G3, G4. G1, G2, G3, G1, G2. something wrong. P1 is G5, G4, G3, G1. P2 is G3, G5, G4, G2, G1. G5, G4, G3, G1. Right, this is correct. This is G5, G4, G2, G1. Okay, now check. G1, G4, G5, G3. Yes, this is coming. G1, G2, G4, G5. Yes, now it's correct. Now it's correct. In both methods, we got the same transfer function. But both methods, we got the same transfer function. Another sum. So this can be solved quickly. What are the forward paths without drawing that signal flow graph I am writing? You can assume as if it is a signal flow graph. You can assume this as if it is a signal flow graph. Therefore, P1 equal to, this is gain 1, that's why ignore G1, G2, G3. G1, G2, G3. What is delta 1? Then P2. P2 equal to, this is another forward path, G4. That is G1, G4, G3. That is another forward path. We have to find delta 2. Now we have to find delta. Delta 1. What is the first forward path? This is the first forward path. No loop, which is not touching the first forward path. Therefore, delta 1 is 1. Delta 2, this is a second forward path. No loop is there without touching the second forward path. Therefore, delta 2 also equal to 1. In the examination, don't do like this. You won't get any mark. You have to draw the signal flow graph. Delta. Delta means 1 minus sum of gain products of individual loops. This is one individual loop. That is G1, G2, H1 minus G1, G2, H1. This is another loop. This is another loop. Minus G3, H2. Any other loops? One more loop is there. That is minus G1, G2, G3 minus G1, G4, G3. 4 loops are there. L1, this is L1, this is L2, this is L3 and L4. Non-touching loops are L1 and L1, L2 equal to, that is plus. These two are non-touching loops. Therefore, G1, G2, G3, H1, H2. That's all. I found the delta also. Now I can write the transfer function. C of S upon R of S equal to G1, G2, G3. Delta 1 is 1. That's why I am ignoring. Plus G1, G4, G3 upon 1 plus G1, G2, H1 plus G3, H2 plus G1, G2, G3 plus G1, G4, G3 plus G1, G2, G3, H1, H2. That's all. We got the transfer function. First time, you try yourself with the block diagram reduction technique. Block diagram reduction technique. So this we have to move. This we have to move. If we move 4 to 3, or 3 has to be moved to 4. You can do as you wish. If you move 3 to 4, what will happen? G2 is not there. Therefore, G4 by G2 you will get. G4 by G2. If you move 4 to 3, what you will get? G2 is excluded. That's why H1 will be multiplied by G2. H1 will be multiplied by G2. That's all. Anything you can do. Suppose let us move G4 to G3. Here you will get G2. Then you can simplify this by using 7th rule. This also can be used by 7th rule. This can be solved by using parallel 2nd rule. That's all. Then multiply all the 3 blocks. Only one feedback path will be there. Finally. So in 5 steps, you can find the transfer.